The cosine rule. Proof. Acute angle triangle. Given triangle ABC with all angles acute, to prove that a squared is equal to b squared plus c squared minus 2bc cos a. Construction. First of all, we're given triangle ABC, and with triangle ABC, we want to prove that a squared, as this side, the square of this side is equal to b squared plus c squared minus 2bc cos a, which is the cosine rule or formula. So what do we need to do in order for us to be able to prove this to prove that this is true for as cosine rule? We need to draw a perpendicular from C down to line AB, which is this part of the triangle, and to meet line AB at D. So now with that done, proof. In triangle BCD, we need to analyze certain things. So from here to here is the side C. So D from here to here is a distance. If from A to D is X, then DB would be, so from here to here is the total distance, and here to here is X. That means here to here would be C minus X to get this distance. So proof. In triangle BCD, this triangle here, D is 90 degrees. Let CD be H, which is the height of the triangle. AD is equal to X. So A to D, let it be X. So if A to D is X, then but DB is equal to AB minus AD. So DB, which is this distance from here to here, DB is equal to AB, which is C, minus AD to get this distance. That's why DB is equal to C minus X. So now remember that we are still working with triangle BCD. So we're going to say from Pythagoras theorem, our opposite. Pythagoras theorem states that the sum of the square of any triangle is a triangle. These are hypotenuse, and then if this is angle theta, any side facing the angle here is our opposite. So let's, in this case, opposite, and the side facing the right angle triangle is the hypotenuse, usually the longest side, and then the third side is the adjacent. So we represent this with letters theta. They will say here is X, Y, Z. So Pythagoras theorem states that the square of the square of the longest side, y squared, is equal to the sum of the squares of the other two sides of the right angle triangle, x squared plus z squared. So the square of the hypotenuse is equal to the sum of the squares of the other two sides of the right angle triangle. So from Pythagoras theorem, remember we are considering triangle BCD. So from Pythagoras theorem, h squared is supposed to be a squared is equal to h squared. Our hypotenuse is a squared, h squared plus c minus x squared. So a squared is equal to h squared plus, when expanded, give us c squared minus 2cx plus x squared. Let's call this equation 1. So in the right angle triangle ACD, ACT, h squared is equal to b squared. Okay, so if we go by the rule here, b squared is equal to x squared plus h squared. So start with h squared. H squared is equal to our hypotenuse, then b squared minus x squared. So if we, same thing applies here. Instead of starting with y squared, which is the squared, we can make any of them solid with the formula. So if you make x squared the solid formula, it's now y squared minus z squared. This is exactly what we have here. We choose a squared to be the solid formula because we want to substitute this into equation 1 in place of h squared. Equation 2. So substituting equation 2 into equation 1 in place of h squared, we're going to have a squared is equal to b squared minus x squared plus c squared minus 2cx plus x squared. So what do we notice? If we rearrange, we square that minus x squared plus x squared will cancel. So this will cancel out. So a squared is equal to b squared plus c squared minus 2cx. So we call this our equation 3. Equation 3. So we're going on to say, but in triangle ACD, cos A is equal to, in triangle ACD, cos A is equal to, so for the cosine ratio, using cosine ratio, just like we did for sine ratio yesterday, we have to catch this is cosine ratio, where C is for cos theta, the cosine of the angle, and A is adjacent, and H is hypotenuse. So for using cosine ratio, cos A, which is this angle A, is equal to adjacent x over hypotenuse x over b. So x is equal to b cos A. So next, substitute x to b cos A into equation 3 for x. For x means in place of x in this equation. So this will give us a squared is equal to b squared plus c squared minus 2. So 2cx, in place of x, we're going to be b cos a. So that would now be 2c times b cos a. So instead of x here, where we had x, we have replaced it with b cos a. That was the instruction from this part of the sentence. So let's open our bracket. A squared is equal to b squared plus c squared minus 2c times b cos a will give us 2bc plus a. And this is our formula for, this is the cosine rule. And this is exactly what we have here. So we have been able to prove the theorem. So we want to carry out a proof for the cosine rule when angle A is obtuse. That's the second alternative for proving that the cosine rule a squared is equal to b squared plus c squared minus 2bc cos a is true. But this time around, we're going to use a case where one of the angles is obtuse. So given triangle ABC with angle A obtuse, so this was the triangle we're given, triangle ABC, and then to prove that a squared is equal to b squared plus c squared minus 2bc cos a. So what do we have to do in order to prove that this is truly the cosine rule? We need to construct a line, and that means we need to draw a perpendicular line from C, which is this broken line from C to meet AB at produced at this. So we extended line AB down to this point where we dropped the perpendicular. So where the perpendicular and line AB meets is will give us the height of the triangle as D. So proof in triangle BCD. So first of all, our focus is triangle BCD. In triangle BCD, D is equal to 90 degrees, which is this angle. So let's see the BH, which is the height of the triangle, and AD X. So from Pythagoras theorem, A squared, when we're looking at triangle BCD, A squared is equal to AX squared, X squared plus X squared, A squared is equal to H squared, A squared plus C plus X squared. So the whole of these adjacent will give us adjacent, adjacent triangle line BD, which is the whole of triangle BCD. We are looking at triangle BCD. So for triangle BCD, the adjacent is from here to here, which comprises DA plus AB. So DA is X and AB is C. So which will give us C plus X or X plus C. Now give us C plus X squared. So this will give us A squared, H squared plus C squared plus 2cx plus x squared, x squared. So let's call this equation 1. In the right angle triangle ACD, h squared is equal to b squared minus x squared, b squared minus x squared. We'll call this equation 2. So substituting a squared is equal to b squared minus x squared into equation 1 in place of h squared. We're going to have, so h squared is equal to b squared minus x squared, and we have h squared here, so we're going to put the whole of this in place of h squared in equation 1. So a squared is equal to b squared minus x squared plus c squared plus 2cx plus x squared. And so minus x squared plus x squared is going to cancel out. X squared is equal to b squared plus c squared plus 2cx. Call this equation 3. But in triangle ACD, C angle AD is equal to 180 degrees minus A. Why? What's the reason? Sum of angles on a straight line. So A for triangle BAC, the angle here is obtuse A, but for triangle CACD, for triangle ACD, this is what we are considering. Yeah, in the right angle triangle ACD. So triangle ACD, this angle here is acute, while this one here is obtuse. So together they make angles on a straight line. So we have something like this. This is a straight line. BAD is a straight line, and then we have the obtuse angle here, and then we have the acute angle here. So if here is theta, then this angle will be 180 degrees minus theta. That's the implication. So for triangle ACD, angle A, which is the middle letter here, and so that anytime your angle is represented like this, the middle letter is the letter that the angle is on. So triangle angle CAB is equal to 180 degrees minus A, and the reason is sum of angles in a straight on a straight line, sum of angles on a straight line. So also from triangle it's also triangle ACD, cos 180 degrees minus A is equal to, so the cosine of this cosine ratio in this triangle ACD will give us adjacent to hypotenuse, which is x over b, x over b. So therefore x is equal to b cos 180 degrees minus a. We know that since this place is 180 degrees minus a, that means cos is in the second quadrant, cosine is in the second quadrant, and we have our path ATCS. Here all the trigonometric ratios are positive, such as sine, cosine, and tangent. But in the second quadrant, only sine is positive. In the third quadrant, only tan is positive, and in the fourth quadrant, only cosine is positive. So where this ratio means that the trigonometric ratios are in this quadrant, they are greater than 90 degrees but less than 180 degrees. And in this quadrant, cosine is negative. So if it's cos 180 degrees minus a, so we are going to say but cos 180 degrees minus a is equal to minus cos a. Why? Cos is negative in second quadrant. That's the reason. So like I said in the first class, always state your reasons. Always state your reasons. Don't assume that your teacher knows what it implies or your examiner knows what it implies. Always state your reasons. Like you can see, I stated the reason here and I'm stating the reason here also. Okay, so this will give us, so here we should substitute this into this equation. We're going to have therefore x equals to minus b cos a. That's the implication. So let's call this equation 4. Now the next thing we're going to do is to substitute this equation 4 into equation 3. I'm going to substitute 4 into equation 3 in place of what? X. In place of x. So that will give us a squared is equal to b squared plus c squared plus 2c brackets minus b plus a. So that will give us a squared b squared plus c squared. Now this part 2c is multiplying minus b cos a, so minus times plus will give us minus. So 2c times b will give us 2bc plus a. And say hence we discover that this is exactly what we aimed at proving at the beginning. So I say hence in both acute and obtuse angles, the cosine rule is a squared plus b squared plus c squared minus 2bc plus a. We can also go on to say similarly by considering angles b and c, the cosine rule can be obtained we obtain as b squared. If you are considering angle b, we have b squared minus a squared plus c squared minus 2ac plus b, and c squared is equal to a squared plus b squared minus 2ab plus c. So all together, so this is the cosine rule. Therefore, the cosine rule is a squared equals to b squared plus c squared minus 2bc plus a, b squared a squared plus c squared minus 2ac plus b, c squared is equals to a squared plus b squared minus 2ab plus c. So that's the cosine rule. So when is the cosine rule used? When is the cosine rule used? When do we use the cosine rule? What are the conditions that need need to be fulfilled or met before the cosine rule could be used? The conditions are first of all, two sides and the included angle are given. So two sides and an included angle must be given for the cosine rule to be used. Yesterday, the last class we looked at the sine rule, and also there was something similar to this. But when we're talking about two sides and an included angle, for cosine rule, we mean something like this. Let's say these are our triangle. If these two, we're talking about two sides. So if we're given, let's say, a b c, and we're given here to be 4.2 meters, here is 3.2 meters. So these two sides are given. The included angle must be between the two sides. So once the included angle is between the two sides, either here, must be between these two sides like this. Let's say here is now theta. Then this is the only condition that warrants the usage of the cosine rule. If the included angle is not between the two sides, then we can't use cosine rule. Rather, we are to use the sine rule. So if the angle is here, now you can see that this angle is opposite one of the given sides, and then the other side is opposite a known included angle. So that will warrant the use of the sine rule. And if the angle is here, that will also warrant the use of the sine rule, because one of the given sides is opposite an included angle, and the other given side is opposite a non included angle. So that would be that it is the sine rule that would be used in this case. But if the included angle is between the two given sides, as in this example, then that's when we can use the cosine rule, which is the first condition. Then if this is not so, if three sides are given and no angle included, let's in this case we have 5.3, assuming so 5.3 meters, then we should use the cosine rule. So that's the meaning of the second this second rule. All the three sides are given. So when all three sides are given and no included angle, that means we have to use the cosine rule. So these are the two conditions that must be met if we have to use the cosine rule.